So I want to focus mostly on some of the less well-known features that are inside of DevTools. But to begin with, I'm just going to go through the fundamentals and try to point out some of the less well-known features in DevTools. So the main feature is that it allows you to pause execution and then step through your code line by line. And that enables you to kind of observe your code and see at what point things start going wrong. So at each point, it shows you the kind of local variables, and you can see if their values match what you expect them to be or if it's something different. To set a breakpoint, you just click on a line number, and then next time that line is running in Chrome, Chrome is going to pause and give you control about how you step through your code. Instead of clicking on a line number, you can also use a debugger statement, and that is the same thing as clicking on the line number, but you can do it right in the editor without having to find the right file inside of your DevTools code. In addition to showing you the local variables, Chrome is also going to show you the call stack, which just explains, okay, why is this function running? So what were the functions that led up to this function being called? By clicking on the individual call frames, you can see the local scope in each function. And those values are also then available in the console for you to work with. In JavaScript, a common problem you're going to run into is asynchronous code. Because every time you make an asynchronous call, you're going to use all the context of why that call was made. So in this example, you can see we call the render to-do list function, but we don't understand why our to-do list is being rendered. But Chrome has a checkbox, an async chunk in the top right, and if you enable that, Chrome is going to persist all the state and information and the call stack from that point when the asynchronous call was made. So in this case, you can see that we were initializing our app, we were loading some data, and then because we now have the data, that's the reason why our to-do list is being rendered. And you can see in this example, it's using timers, and it's also using promises. But if you use something like an AJAX request, the asynchronous call stack also works. And you can actually go back up in a call stack and see why your AJAX request was made with the parameters that it was made with. Another thing that's easy to miss is that after you step over a return statement, you can find the return value inside of the scope pane. So in this case, it's just a simple value. But if there's something more complex, you can right-click on it and store it as a global variable. So any local scope variable you can put in the console, and in there you can then call functions on it or process the data in some way. And if you log an object to the console, you can also use store as global variable to access it and work with it in a better way. Another issue you can run into when kind of working with variable values in DevTools is wrapper objects. So if you try to display a backbone model or an immutable.js model, Chrome isn't going to show you the actual contents of that object. It's just going to show you the internal data. So in this case, if I display this immutable.js object, it's showing me all these internals from immutable.js that aren't really relevant to me. And it's quite difficult to actually make out, OK, at what point, where is my actual data? But Chrome has a feature called custom object formatters. And in this case, I'm using a tool called Mutable DevTools. And it displays not the actual object representation of this object. And instead, it renders just the content that is relevant to me, rather than displaying the immutable.js internals. So once you've paused, you want to step through your code. And I think most of you are familiar with the basic stepping controls. You can click resume to just continue running until you're at the next breakpoint. Most commonly, you're probably going to step over the current function, just go to the next line and see what the next step in your code is. If you have a function call on the current line, you can also step into that function and debug it in more detail. Or the opposite of that is you can step out of the function, just run until the end of the current function, return, go up in a call stack, and then pause again. But Chrome has a few features that allow you a bit more control over how you step through your code. A common issue is that you want to exclude certain files from your code, and you can do that using blackboxing. So most commonly, you're going to use that with library code like jQuery or underscore. And in this example, I'm calling the underscore filter method to filter an array based on the function, a callback function, that decides whether or not to include the array value in the new array. But normally, if I try to debug my callback function and step into this filter call, I'm not stepping into my callback. I'm stepping into all this underscore.js code, which is difficult for me to understand. And it makes it hard for me to actually find, OK, what point am I actually going back to my own code? But if I blackbox the script by just right-clicking and selecting blackbox script, the next time I try to step into this filter call, Chrome is going to run through all of the underscore code, and it's only going to pause again once it goes inside a file that belongs to my own application. Another feature is restart frame, and it's different from all of the other stepping features because it allows you to step backwards in your code. So if you hit a breakpoint, you can actually run the code that ran before I hit it. So for example, I have this calculated holiday cost function, and I'm pausing at the end of the function, and I can see, well, the cost is not a number. So that tells me something inside of my function went wrong. And if I right-click on the call frame and select restart frame, Chrome is going to jump back to the top of the function and allow me to step through that function again. So I can step through it line by line. I can see, well, at what point does my error get introduced? And I'm running get flight cost, and everything is still fine. But then when I step over get hotel cost, that is where my error is being introduced. So again, I can use restart frame to go to the top of the function, and this time I know what function is broken, and I know which one I want to step into. So when I do that, you can see the problem is that I'm trying to pass this value that isn't really a number, and that is why I'm getting the not a number value, and my application is broken. So restart frame is a really useful feature, but it's not true time travel debugging, and has a bunch of limitations. So for example, if you modify a global variable, that isn't going to be reset, because Chrome doesn't persist all of that state. And likewise, if you modify a parameter value, that isn't going to be reset either. One feature Chrome recently added is called Never Pause Here, and the name pretty well explains what it actually does. So for example, you can use it to disable the debugger statement. So if you tell Chrome to never pause on a line with a debugger statement on it, it's going to ignore and disable that debugger statement. And later on, we're going to see another use case where you can use Never Pause Here. At some point, while debugging, you're going to run into compiled code, which is difficult to debug. So in this case, it's just minified code, which is very hard to actually see what's going on. But more commonly, you're probably going to use something like Babel. And the solution to that is source maps. Or first of all, if you just have compiled code, you can just click a Prettify button in Chrome, and without having any other additional tooling, you can just get some formatting and have a better understanding of what your code actually does. But normally, really, you want source maps. And source maps describe the relationship between the source code that you wrote and the code that your compiler generated. So you have to tell the compiler, in this case, uglify.js, that you want to generate a source map. And then the next time you try to open your code in Chrome, Chrome isn't going to show you the minified code anymore. Instead, it's going to show you the original source code. So let's have a look at the source maps file and what it actually contains. There are two important things here. One is the sources array, which is a list of all the original files, and that is how Chrome can access the original source code. And the other is the mappings. And the mappings look kind of cryptic because they're these alphanumeric values. But really, each of these alphanumeric values just is an array, and the array just describes, OK, in my compiled source code, this index, this column, this line, and this file refers to this other place in my original source code. So when you create when you create a breakpoint in your source map code, Chrome knows where in the compiled code you want to pause. However, actually, in practice, you're going to run into issues with this. So for example, in this case, I'm trying to set a breakpoint on line 3, but actually, Chrome is moving a breakpoint further down to line 5. And there are lots of reasons why that happens, because there are all these, there is a difference between a code that you are trying to debug and the code that you wrote, and the code that's actually running inside of Chrome. So for example, the reason why this particular thing is happening is because my 3 different statements to kind of add up the cost again and again has been merged by my compiler into one single statement. And that means Chrome can no longer pause on the individual statements. Another issue is that Chrome doesn't actually map the compiled variable names back to the original variable names. So in this case, you can see all the minified variables. But if you use something in Babel, you've probably run into it that you try to access a value in the console or try to hover a value, but actually Chrome doesn't recognize it anymore. But it's actually kind of odd that Chrome doesn't it doesn't recognize that value anymore, because the source map specifically has this names array, which should really tell Chrome what the relationship is between the compiled variable name and the variable name in your original code. But in practice, none of the kind of major browsers are using it at the moment. But if you try Chrome Canary at the moment, there is an experiment that actually reads in that names array to actually show you the original variable name. The last issue you have with source maps is blackboxing. There are a lot of situations where when you use it with source maps, blackboxing doesn't work correctly. And it can happen that if you try to step into a blackboxed file, rather than stepping straight through it and ignoring it, Chrome is actually pausing into a blackboxed file, which shouldn't really be possible. But again, this is something that there is an open issue for that somebody at Google's kind of working on to make it better. Everything I talked about so far kind of assumes you know your code fairly well, so you know a file and a line number that you want to pause on. But in practice, there are a lot of situations where you are not very familiar with the code, either because you haven't worked on that particular bit of the code before, or because you think you understand the code that you wrote, but then you show it to Chrome, and Chrome has a completely different interpretation. So for that, Chrome has a bunch of behavior-based breakpoints that allow you to observe a behavior, and then Chrome can show you the code that is responsive for it. So for example, you can say you want to pause when an API request is made to a certain endpoint, or when the text of a button is being changed. And I want to demonstrate these breakpoints using the To-Do MVC app. So this is Blackboxing To-Do MVC, and it does the kind of normal to-do application things. So you can add to-do items, and you can mark them as done. And specifically, I'm interested in the marking as done functionality. So the first thing I want to understand is, what is the code, what is the actual event listener that runs when I change this done state? And to do that, I can use an event listener breakpoint. So I go into sources, and on the left, you can see all the breakpoints that are currently activated. Right now, I don't have any, but if I go into event listener breakpoints, I can tell Chrome I want to pause whenever there is a click event being handled. So next time I try to change one of these by clicking on it, Chrome is going to pause inside of the event listener. In this case, the application is using jQuery to actually create the event listener. So I'm pausing in code, and it makes it difficult to find the application code that I need to debug. But this is a good example of where you use blackboxing. So if I disable this file and continue, and then try the same thing again, you can see this time I'm not pausing inside jQuery anymore. It's hiding those two call frames and going straight into my application code. And if I step into that line, you can see all this really does is when I click on this button, on this toggle, it is changing the completed value on the model that is used to render this particular to-do item view. So now I understand that clicking on the button changes the model. But by looking at the app, I also know that at some point the model change propagates to a DOM change. And to understand how that works, I can use a DOM breakpoint. So I can find the DOM change that is actually happening. So I inspect the element and just collapse this. And then if you look at the source code and how it changes, every time I activate or deactivate an item, the completed clause is added or removed. And by right-clicking on this, I can click break on and then attributes modifications. And in this case, the attribute I'm interested in is a class attribute. So Chrome is going to pause every time that attribute is being modified. So now if I do this again and change this item, Chrome is going to pause. It's still going to go into jQuery, but if I can go up and go back to my to-do view, and it's pausing in the render function, and it's toggling the class on my to-do view element, based on the value of the model's completed value. And if I go back up the call stack, I can also see that this still originates from my original model change. One feature of this application is that when I reload it, all the data is persisted. So if I add a new to-do item and reload the page, that's still available. And the way Chrome does it is using local storage. So if I go into the Resources tab and local storage, I can see that each individual to-do item has a representation as well as a local storage item with the data in it. And I want to understand how does the persistence actually work? What part of the application code is responsible for it? But unfortunately, Chrome doesn't have a breakpoint that allows me to pause when our local storage data is being modified. But I can actually simulate that myself using a debugger statement. So I can use this, do this by overwriting the local storage.setItem function. And all that I want to do is pause, and I do that with the debugger statement. So the next time this application tries to access local storage, Chrome is going to pause and show me what it's doing that. So it's pausing inside this little snippet. And I can see in the call stack, this is the setItem call. And in the call stack, you can see this file, Backbone local storage, which is a plugin that handles all the persistence. So if I wanted to, for example, replace my local storage persistence with server persistence, I could just replace this plugin with different code. So I can find out what code is responsible for storing the data and then replace how that works. There is one problem with this, because if I now try to interact with my app, it no longer works, because I overrode the setItem function that my application was relying on. So in practice, in a lot of cases, you want to store a reference to the original function. So in my new function, I still have my debugger statement, but I'm also calling the original function with the key and the value that I want to store. And I'm returning the return value of that. And by doing that, my application can no longer tell the difference between my custom function that I used and the native local storage function. So everything is still working exactly the same, because my application isn't impacted by this change. And you've seen you can use a debugger statement to kind of create a custom breakpoint to debug certain functions that are called in your application. But you can also do the same thing for object property access. So if you have an object that's been written to or read, you can pause at that point. So you can use that, for example, if you want to find out what part of the code is changing the cookie. So that is just a documented cookie assignment that you can pause on. And likewise, if you have a behavior in the browser where some code keeps changing the body of scroll to position in the wrong way, you can also pause on that using body of scroll top. One way to do that is using object.define property. So you have your object with this documented body. You have the scroll top property. And then you can pass in a setter and a getter. In this case, all I want to do is pass in a setter function. And then when body of scroll top is assigned to, and when the scroll position is assigned a new value, Chrome is going to pause and show you, OK, what part of the code is actually responsible for that. And doing that has some problem again, because as before, now the original functionality has stopped working. So if I actually assign body.scroll top now, it's no longer going to actually change the scroll position on the page. And you can fix that, but it can be quite tricky to actually find the original setter method that is responsible for updating the scroll position. So I've been working a library called JavaScript Breakpoint Collection. And it just gives you a debug property set function that takes care of adding the breakpoint and then also calls through to the original setter method. Or alternatively, there's like a simpler version, which is like debug scroll. And it combines a bunch of different things that can be responsible for a scroll change on a page. So if this position on the scroll position on a page is changing, you don't know if it's a body or scroll top assignment or a window scroll to or window scroll by. But using debug scroll, all of those are going to be combined, and you can find out which is responsible for that change. So if you want to try that, I have a Chrome extension that kind of contains that, which is the easiest thing to use. I want to talk a bit more about pausing exceptions, because you're going to run into some issues when you're trying to use it. So I tend to have it enabled most of the time, because it just makes it a lot more obvious when an error occurs on a page, because Chrome is going to pause rather than just showing an error inside of the console. But the first issue you're going to run into is that when you look at the console after pausing an exception, you won't actually be able to see the error message there. The error message only appears after you click on resume. But clicking resume means you're going to lose all your local debugging state. So it's not a good solution. But luckily, most of the time, Chrome is going to show you the reason why you've paused at the bottom of the call stack. And in the case of pausing exceptions, it's also going to show you the error message there. So you can find out what error occurred at that line without having to lose your state. The next issue you can run into is global exception handlers. So certain frameworks or test runners are going to try to handle your exceptions for you and show them to you in a better way. But that means when you actually try to debug your application, Chrome isn't going to pause in the right place anymore. So in this case, I'm initializing my app. And if the app introduction fails and there's an exception, I want to report that exception to the server so I know that something went wrong on the client and I need to look into it. But that also means I'm no longer pausing in the right place, and it makes it difficult to find where the original exception occurred. But if you look at the screen, you can see there's this pause and export exceptions checkbox, which tells Chrome to pause on every single exception that's being thrown, even if it is eventually being handled in a try-catch block. So the next time, if I try to, there's an exception, Chrome is going to pause. But unfortunately, again, it's not really where I wanted to pause. And that's because my application is using exceptions for control flow in some places. So in this case, I'm trying to detect whether a string is valid JSON or not. And one way to do that is just using the JSON as path method. And if it throws an exception, I know it's not JSON. Whereas if it passes validly, I know everything is fine and it's JSON. And there's nothing wrong with this behavior. So my application is fully functional. And this exception isn't indicative of anything being wrong in my application. But it also means that Chrome is going to pause here again and again, because my application is using isJSON a lot, but it isn't actually a problem. So again and again, I'm pausing somewhere where there is no actual defect. But again, this is something you can solve using never pause here. So if you tell Chrome to never pause in that particular line and then continue, you can see the next time Chrome is actually going to pause in the particular line of the code that is actually broken, and I can actually find my actual defect, and I'm pausing in the right place, and I have all the kind of local debugging state that I want to have. The last thing I want to talk about is remote debugging. And to understand it, a good way to get started is just to understand that DevTools are kind of separate from Chrome Desktop. So DevTools is just a web app. So it uses CSS, HTML, and JavaScript to kind of build its UI, whereas Chrome Desktop is this kind of C++ application with V8 and everything. And the way this works is that it's this WebSocket connection between the two. And DevTools can say, well, I want to set a breakpoint in this particular line. And then when that breakpoint is hit, Chrome is going to send things like a call stack or the local variables to DevTools, and DevTools is going to display that. And the fact that these two things are separate means that you can actually replace what you use on either side of this interaction. So for example, using remote debugging, you can connect your Android phone to your computer with a USB cable, and then enable debugging on the phone, and you can see all of the pages that are open on your Android phone, and in DevTools, select which page you want to debug on your phone. And if you don't have the right Android phone available, you can also do the same thing using a virtual Android device. And in a similar way, you can use DevTools to debug Node applications. So this is a tool called Node Inspector. And if I run it, it's going to do two things. It's going to run the Node process with remote debugging enabled. And it's also going to open a Chrome window with that's loading the DevTools. And the DevTools then are able to connect to that WebSockets connection on my computer and get access to the debugging data. And in a similar way, you can swap out the DevTools themselves. So you can debug directly in your editor, and a bunch of editors have integrations with the Chrome debugger protocol. So there's a plugin called Sublime Webinspector, and you can just use it to set breakpoints directly inside of Sublime, and it's going to show you all the kind of usual things. So it's going to show you the call stack and kind of local variables. But you can see that Sublime isn't really built for that kind of functionality because it's all very text-based. But if you try something like Visual Studio Code, you can see there is a very similar experience as you have in DevTools. So if you want to learn more, I think the best resource is DevTools Tips by Uma Hansa, which is just a collection of tips, but each one comes with a GIF that kind of explains how this code actually works. So if you want to find the links to that or to the slides, you can go to that URL. So thank you.